So we're going to start off this morning with a fairly brief presentation about the process that a little bit more information, or some of it recapping a little bit of information that you may have already heard from Jeff and Marty during the week, just so that everything's fresh in our minds. And also starting to look at the process that we might be going through this morning, the typical things you'll expect, a couple of different ways of going about this process. So let's get going. So what we're here to talk about is using Visual Studio to do traditional Synergy development, and that means that right now with our initial support you can basically edit traditional Synergy code with all of the enhancements and intelligent editor stuff that you would expect in an advanced IDE. You can produce object files, object libraries, OLB'S and DBR'S. And as Marty and Jeff showed you yesterday, you can also debug that code in the Visual Studio environment. If you do nothing, then when you run in debug, it will simply pop up the good old Windows traditional Synergy debugger for you to debug the code. And as Jeff showed you yesterday, and we'll mention again later in this presentation, there's that environment variable that you can set to turn on the new experimental debugger and play with the fully integrated debugging models as well. Remember that Visual Studio supports build configurations, as does Workbench, but it was a little bit less obvious in Workbench. It wasn't quite so in your face in the UI, and most people tended to build with one particular configuration, which is probably likely going to be the case in this environment too. But bear in mind those two drop downs at the top, so debug and release versus x86 and x64. So you need to obviously make the most appropriate choice for whatever your environment is. You know, bearing in mind that if you're a toolkit app, or even if you're not, if you're using ActiveX controls and you've only got 32-bit ActiveX controls around and stuff like that, then clearly you're going to need to make sure you're in a 32-bit configuration. Also bear in mind that I'm not sure if any of you here are non-Windows people, but bear in mind that traditional Synergy is binary compatible with Linux. So if you are a Linux developer, yes, you can still use this environment to produce your DBRs and OLB'S and so on, and either transport those things then to a Linux system, or use tools like Samba or NFS or something so that those files are actually produced on that Linux system. And if everything's configured correctly, you should be able to go off and still run them. Let's talk about initial capabilities. Well, I guess I already have a little bit. Producing object files, object libraries, OLB'S and DBRs. Pretty comprehensive color coding, IntelliSense, full support for snippets in Visual Studio, and the code beautifier as well, that can really help you if you've got some code that's kind of all over the place, and that control KD key sequence to reformat the code is a very nice addition to what we used to have available in Workbench. Also, we'll talk about this a little bit more as we get through this presentation, but you are going to be using an MSBUILD based build system. So compared to the stuff that you had in Workbench, it's a world apart from that, basically. It has a lot more information about the environment. You have less setup to do. It just kind of learns things from your project. And it's intelligent enough to know what needs building and only build that. So, if you had a project in Workbench that had 1,000 programs in it, which isn't that uncommon, and you hit build, it's going to go off and compile and link all 1,000 programs. Whereas in Visual Studio, if you've just edited a piece of code and you hit build, it will build just that program. So there's some fairly significant advantages in terms of how this thing works once you've got it all configured. And obviously the integrated experimental debugger as well. Okay, let's talk about, in terms of requirements, what do you need to get into this environment? Everything you need is on the virtual machine, but if you want to try and do this when you go back to your own office on your own machines, then basically you need an appropriate Windows development system. Windows Vista or higher is what Synergy supports these days. It really needs to be a 64-bit environment. If you're doing Visual Studio type development, you really need a 64-bit OS with at least 4 gigabytes of memory. More is better. More is always better when it comes to memory. I would say 8 is a sort of fairly normal developer configuration these days, and maybe even more depending on the type of work you're doing. The Visual Studio installation ships the compilers and stuff that it's using under the hood, but there are other tools in SDE, of course, like the repository and other tools. So yeah, you're going to need Synergy 10.3.3 installing. Obviously, if you're on a 64-bit machine, you're probably going to want, as you always did, both 32 and 64-bit Synergy installing, and including the DBL integration for Visual Studio. So there's no separate installation to get the traditional in Visual Studio stuff there. It's just part of the DBL integration for Visual Studio that you've been installing to get Synergy.net for the last few years. And again, if you haven't done that before, there's no licensing over and above the regular traditional Synergy Workbench type environment. It's the same licensing environment as well. We would strongly recommend Visual Studio 2015. It does work in all editions, Community, Professional, and Enterprise. So if you are one of the lucky people that are, in either self-employed or in a small company with a small number of employees and certain turnover limits, maybe you get Visual Studio for free these days. If not, then obviously you've got to get it through whatever mechanisms you would normally do so. So those are the tools you would like, really nothing over and above what you would already have if you were doing any kind of Synergy.net development. You're good to go. Requirements in terms of your code, there are some requirements. These are probably the biggest two that we'll probably spend some time dealing with, and they've already been mentioned through the week. Strong prototyping is the first absolute requirement at this point, to allow some of the more advanced tooling that you've seen this week and the significantly improved IntelliSense and all the debugging capabilities and all of that sort of stuff, absolutely rely on having full-blown prototypes for all of your code. So that's where most of our time is going to be spent today, in saying, okay, what do we need to tweak in your code? And typically it is little tweaks. We're not talking about major work here. There might be a certain amount of volume to take care of, but it certainly should not be anything that takes any major thought process or effort. It's usually figure it out and, oh yeah, okay, just tweak that little bit. So in this environment, your code will be strongly prototyped, and we'll have some issues to deal with that. And also, again, been mentioned this week, another issue that sometimes crops up, not always, is our bad habit over the years of having circular references between our ELBs. So if you're not familiar with that term, that's basically saying there's a subroutine in one ELB that X calls a routine in another ELB, and then there's something in that ELB that calls back into something in the original ELB. So you've got this, how do you build that one when you need that one, and how do you build this one when you need that one, the chicken and egg scenario going on. Well, of course, with traditional Synergy, the linker let you do stuff like that because nothing was really validated until you came to try and run it, and as long as everything was there at runtime, it was fine. That doesn't happen in this world. So we're going to get started. We're going to go into Visual Studio. We're going to look in the file, new project, and we're going to see our Synergy DE folder that's already got all of the existing Synergy.net stuff in there. And under Synergy DE, you're going to see a new folder called Traditional. And in there, there's the 4 project types that we've been mentioning. So ELB, DBR, well, multiple mainline, object library, and executable library. That 4th one at the bottom there, some of you may need to use. The difference is the multiple mainline, as its name suggests, basically is configured such that every DBL in that project is a program. So you've got 1,000 programs, 1,000 mains essentially, each of which produces a DBR. That's what the multi-mainline project is for, and it will compile and link each file as a program. The traditional application DBR is basically going to create a single DBR from all of the DBLs that are in the project. So it's assuming there's a program and any number of subroutines and or functions and or classes, and it's going to compile and link the whole thing together as one DBR. So you have really those are the 2 primary ways you could configure program projects in later versions of Workbench with the Workbench build system. You are either producing one or many. Once you've created a project, the first place you want to be going probably is the project properties dialogues. It's not like Workbench. In Workbench, when you create a project, the first thing it does is pop up the project properties dialog so you can go and start filling things in. Here, you're going to have to go and select it from the menu or right-click on the new project in Solution Explorer and select properties and go and configure the project properties. You may or may not need to configure the output name. In the project properties, you can see we've got our 5 tabs available here. The tabs, they are tabs, they're listed down the left-hand side there. The first one is application. So the things you might need to do in the application are the output name is basically the name of the OLB or the DBR or the ELB that's going to be produced. So if that is not the same as the name of the project, it depends how you choose to name your projects. You don't have to, but that's ultimately what the name of the DBR or the ELB is going to be. And if you are one of those people who are doing this to target Linux, remember you need to pay attention to case, just like you would in the Linux world. Working directory you may or may not need to mess with. By default, what's the working directory by default? The object directory?
Yeah, the object directory.
Okay. So during a build, if you've ever worked in Visual Studio before, you'll be familiar with the fact that it creates OBJ and bin folders below your project, and it creates temporary files and output files in there by default. So during a build, by default, your current directory is the OBJ directory, or somewhere within there, probably configuration dependent below there. If it's important to build your code that you be somewhere else, for example, the primary case is if you've got .include fred.def, and there's no path specified, so it's important that your current directory is the source directory or your include files directory or something like that, then you would need to go and specify that working directory in that field there. And that basically, it will CD to that location during a build. You don't sit there all the time, so it CDs there during a build and then back to wherever it was. That field does also support logical names, so you can put src : or something like that in there if you need to. The startup object on this dialog also, you're not going to need it initially, but what that does is determine if I'm in a multiple mainline project and I just hit go, start debugging F5, which program is it actually going to start? So that's kind of the default program for this project, if you like. And you can change that through this drop down. You can also change it by right clicking on a source file and saying make this the startup object. So there's multiple ways of doing that. Moving on to the build tab. Again, you will typically you don't have to come and visit this tab, but I would recommend that you do. The one thing you probably want to be doing here is setting the output path. When you create a project, it will have Visual Studio's usual release and debug configurations, and each of those will have an x86 and an x64 configuration. So remember, at all times, you're dealing with at least 4 configurations. And they all default to creating output in the bin folder in I forget whether it's x86 release or release x86, whichever it is. I'm going to guess, what I tend to like to do is to have a single directory. And so basically each project creates its executables below that project. In traditional Synergy, it's more common to have a bin folder or an exe folder somewhere, and everything gets built into that folder. So if that's what you want to achieve, then you want to change the output path for the project under build. And again, that supports logical names like you can see here. Bear in mind, this is the thing you're looking at there is the output path for the current debug x86 configuration that's selected at the top. So to set the all 4, you would have to go and select, one after the other. Or if you drop down those drop downs, you can select all configurations, all platforms, and then set exe, and it's all whatever your logical is or your path, and it will update all 4 configurations at the same time for you. But it's very easy to forget to do that sometimes, and you build in a certain configuration and your files go over here, and you build in release mode and they're over here, and it's like, what's going on? So pay some attention to that. The other stuff in there should be pretty much good to go unless you start creating custom configurations and stuff. The next one is the biggest one by far. Again, Marty showed this the other day, compiler options. So basically, here's where you get to say, well, we always compile with -xt, or we always do a whatever it is, a QRelax something or other. So basically, you just need to put a bit of thought and maybe refer to your existing build system. If you're building with Workbench, then you've got a similar page in the Synergy DE options in Workbench that you can go and refer to. Well, we're using these options. Let's make sure we got the same ones set in this environment. So you just need to think about, what options do we have? Also in your environment, remember there's another way of specifying default compiler options through the syncmpopt environment variable. So it's probably a good idea to just do a set space syn and make sure that syncmpopt isn't set. If it is, make sure you put the same options in your build environment. So that's the compile tab. I'm skipping down over environment variables intentionally right now because I don't believe most of you need to use that anymore. This is the new one that was talked about the other day, so common properties. So this is brand new addition in Visual Studio, and it's now also been backported into all the Synergy.net projects. And essentially what this lets you do is set environment variables that you can share between multiple projects or potentially all projects. I believe when we do a new project, we turn this on by default. What you almost certainly all of you want to be doing is coming to this page, making sure the Use Common Properties box is checked, and that's a great place to set up all the environment variables that your application needs. And now you only have to do this in one place. Prior to this, you would have been using the Environment Variables tab, which basically looks and feels very similar, but that is project specific, so you'd have to potentially replicate settings across all of them, or set up a batch file to set them externally and then launch Visual Studio, which isn't a particularly pleasant experience either. So the The Common Properties tab is probably where you need to be spending a little bit of time doing initial configuration, setting up whatever environment variables your build environment needs. Remember, you don't need to spend a ton of time setting up all your data logicals. Ultimately, you will. So it's just those logical names that you need to refer to anything that you're using in source code. So how do you get to include files and things like that? You don't even typically need the ones that if you're using batch files to build, you might have logicals that point to all these different source folders. You're not even going to need those unless you use them for include, because now the build system is going to be based on just what's in the Visual Studio project, and it already knows where stuff is. So really it's just those environment variables that either affect the way the compiler works, so things like DBL-opt is another thing you might need to look at and say, well, we set options 3 and 19 and 45 or whatever they are, and anything you need literally within the source code that is used at compile time, predominantly include. And if you do have different requirements for different projects, like, this project has an include folder over here, but this one uses a completely separate one, that's when the environment variables tab would come into play. So these are project-specific environment variables and will override anything that, if you've got the same environment variable in common properties and environment variables will win. MSBUILD macros, when you're setting up things like output paths, or actually more often, I like to use logicals now that we've got that support in things like output path and working directory and stuff like that. But when you're setting up the values of logicals, it's great to be able to refer to, root things off the location of the current solution that you're working in or the current project. So these, I tend to call them MSBUILD macros or MSBUILD variables, whatever you want to call them. These are examples of many more, but these are the typical useful ones. So $paren solution dir, project dir, configuration translates to release or debug the current config, $platform tells you x86 or x64. So these are a great way of setting up the values of your logical names that you're going to use for the location of output path and things like that. And I'll show you an example of an environment that's configured to do that kind of thing in a minute. So setting output path, bear in mind, actually in the demo environment I'm going to show you in a minute, I have not yet done this. I've literally targeted a single directory regardless of what configuration I'm in, which is probably not a great idea and probably not what I'll do long term. You probably do want to take advantage of the fact that you can target different folders depending on is this debug or release an x64 versus x86, and therefore using those $configuration, $platform and so on variables to set up the value of your output directory is a great way of doing it, because now you don't have to provide 4 different logicals and use different ones in each project. You just set exe based on these, and then at development time, depending on which configuration you're in, that logical gets set to that value at that time. And then you use that to be your output path or working directory or whatever you need. Again, I think I've already mentioned these things now a couple of times, but think about DBL-opt. A lot of you quite often have DBL-opt set to change the default if statement behavior or whatever it is. So again, just take a peek around your current environment and see if DBL-OPT is set as an environment variable. And again, make sure it is in this environment too. And think about, compiler options we already mentioned, syncmp opt, or maybe you just need to go, if you're building with batch files or script files, just go take a peek at the DBL commands in there and make sure you're replicating the same build environment in this environment. So, how are we going to get started? Well, there's really a couple of ways you could go about this. And it really depends what your starting point is. The first way you could go about this is just build it from scratch. And that's a reasonable approach. It's not something that should take a huge amount of time unless you're one of these unlucky people who've got one big directory with 4,000 source files in it, and some of them are programs, and some of them are subroutines, and some of them live in one library, and some of them live in another library, and you don't have that information to hand other than filtering through, batch files and trying to figure that information out. If you are, that might be, well, I guess you've got to get there somehow. But if you pretty much have a good handle on these files make up that OLB, and these files make up that ELB, and these are my general ledger programs, and that kind of information, then just setting about with a blank environment and saying file, new project, ELB, add the files in, set up the options, build, see what happens, fix it, move on, that kind of thing. It's a reasonable approach. That's the way, one of the demos I'll show you in a moment, that's the way I set it up, and it took me an hour and a half, I guess. Not to get everything building, I'll be honest, but, well, actually it did because it was prototyped already. But to work through that process of creating the whole hierarchy of all the projects It's not that bad if you've got a clear understanding of what your goals are at the outset. What I would strongly recommend, regardless of how you approach this, whether you do this or try the conversion that I'll talk about in a moment, is I would strongly recommend that you start with the lowest level library. So most of us will have, a couple of libraries and a bunch of programs maybe in subsystems. Some of us may have 3 or 4 libraries, and usually if you think about it, you can draw the hierarchy and say, well, this is the very lowest level, there's stuff in here that calls this one, and this one's application level subroutines, and then programs. So think about that hierarchy and then pick the very lowest level. So the bottom subroutine that's got the real foundational level subroutines and functions, or classes maybe these days as well, that's where you need to start. And really what I would strongly suggest is try and get that building fully before you then move on to the next one. If you just create an environment and dump all 5,000 source files into it and hit build, chances are that build is going to take a long time and you're going to get a lot of errors to deal with all at once. And it kind of muddies the waters. If you address the few errors you get at the lowest level and that's fixed and that works, then you move on to the next level and the next level. It tends to be a lot easier process. Establishing project references. So clearly if you've got libraries and programs, we need a way of specifying this program links against that ELB, or this ELB links against that ELB, or object library, object file even, regardless of what it is. And the way that happens in Visual Studio is through references. So under the project that you create, there'll be a special folder called references. By default, if you create a new project, it will have nothing in it. If you do a conversion from Workbench, it may be pre-populated with some stuff, depends on your Workbench environment. And basically, you just right-click on that folder, just like you would in .NET projects, and you say add reference, and it brings up a dialog, and you can either browse, if you're looking for our SynXML.ELB, that it'll be in there in one of the tabs in the Synergy area on the left there. If it's one of yours, you hit browse, or maybe you've recently picked it, so you just pick it from the list and go and find the other project that you're referencing. So maybe I'm in a programs project trying to reference an ELB project. So you're not browsing for the ELB file on disk, you're browsing in that scenario for the other project that you're trying to reference that produces the ELB. Occasionally, we've come across the scenario where there's a DBO file out there that gets linked against specifically. I've come across 2 scenarios. One, the source code was lost 20 years ago, and all you've got is the object file. And the other scenario is they're going to ship you a DBO file to link against. So if that's the case, you can actually add a reference to a DBO file as well, and it will achieve what you want it to achieve. Okay, prototype-only references. Jeff mentioned this one yesterday. One of the things that you might get into, if you find yourself hitting that circular reference thing, then the guys came up with a pretty smart way of dealing with that. And that is basically in the project where the first project can reference the second one, but having done that, Visual Studio will not let you have this one reference that one. It's going to complain about that. So to resolve that scenario, you need to figure out which routine up here are you trying to call from down here, and you add what's called a prototype reference back to that source file. Okay? And you'll see there's as well as the references folder, there's a prototypes folder. That's what that is for. It's for resolving those circular references. And all it does is it makes the prototype for that routine available in this library as well, so that it can be built independently of the other library, essentially. When you do that, you will, as Jeff mentioned yesterday, you will start running into, well, wait a minute, this thing's defined twice now. It's in this library and it's in this library. So because you've just created a second prototype for the same thing. There's a new QRelax that is intended to resolve that specific scenario. So as well as adding the prototype-only reference, in compile settings for that project, you need to turn on that QRelax allow dupes. Okay? And we'll help you through that process if you come across it. Hopefully not too many of you will. Another way of getting started, SynVS, basically what it does is it reads your Workbench configuration if you've already got one. So if you've got a fully configured Workbench workspace of projects and OLB'S and ELB'S and programs and whatever, then you can give this a try if you want to. Basically what it will do is it will analyze that Workbench workspace and all of the projects it creates, and it will generate a Visual Studio solution and project files for you based on what it finds in Workbench. It will create those projects in one level of subdirectory lower than wherever your Workbench project is. So if you've got a lot of us tend to have a VPW file and then maybe a projects folder with all of our VPJ files in. If that's what you've got, you'll wind up with a bunch of subfolders below there with the same names as the projects, and within those subfolders will be all the Visual Studio projects, okay? Clearly, once it's done its job, you can move them around later if you want and move it up to a different place and edit the solution file and point it at the right path and all that kind of stuff, but that's what happens by default. It also, a lot of us used to use the synset macro in that last tab in the project properties in Workbench where you put synset and all your environment variables and all that kind of stuff. What's it called? The output tab? Open commands, there you go. Those will get propagated, so if any of those are found in the Workbench projects, they'll be propagated as settings into the Visual Studio projects. Although you may want to consider, is it appropriate to turn them into common properties, not environment variables, but that's up to you. And it will propagate references. So if you were using the Workbench build system, where you use the Synergy DE options dialog and set up the compile and link commands and just hit build, and you've already defined this project links against these OLBs and these ELBs, and they will get propagated forward into project references for you as well. So if you've got a comprehensively set up Workbench environment, you should wind up with a pretty comprehensively set up Visual Studio environment, apart from environmental stuff that may have been set up on the outside that wasn't defined within the Workbench projects. So if you relied on a bunch of stuff in Synergy.ini, for example, and just had SFW ini path pointing to it system-wide, that's something you're going to have to go and engineer in. But in terms of the structure of the projects and the files in the projects and the references, every time I've tried it with knowing that I've got a pretty good starting point in my Workbench environment, it's done 95% of the work for me. And then I just typically have to configure a few environment variables or common properties. So look at the environment setup after it's done its thing. The tool is not in path by default. So the tool is syntervs.exe and it's in the Visual Studio extensions folder. So on the VMs it'll be, the path there that you can see at the bottom, Program Files x86, under Visual Studio 14, Common 7, IDE, Extension, Synergex, Synergy DBL integration. So that's where that tool, you will find that tool if you need to try and use it. The -DA option, if you want to give it a try. Jeff, what was the use case we wanted to do with this now? Circular references. Yes.
Yeah, so if you currently have circular references and you're not really sure what those circular references are, DA will try and figure those out for you and break the references.
Right, okay. So yes, so if you know or run into problems because, like Jeff said, because you start in having these circular references around, what DA does is dependency analysis. So it spends a lot of time analyzing everything about your code, and it will finally figure out this one talks to this one and this one talks to this one. So it can help insert those proto-only references for you, but be warned, it can take a while. Define a while these days for a typical environment. What have you seen?
We ran it on one of yours and it took about 15 minutes.
Okay.
I think AgTrax takes about 40 minutes.
Okay. So depending on the size of the environment, if you're really stuck and you just can't figure it out, it's a great tool. It's going to potentially help you out, but you might need to sit there for a little while. If you start running into these kind of circular references issues, grab one of us and call us over and let's have a conversation about it and figure out the best way to go about it. Very few slides. There's a lot of things you could run into, but there's probably a few very common ones as well. So I've just got like 4 or 5 slides here on, these are the things we're almost certainly going to see as soon as you guys start doing this stuff. The first one you're probably almost certainly going to see is type mismatch for parameter X in routine. We're back to the typical prototyping thing. Why are you passing an alpha to a decimal parameter? And vice versa. Because I can, because traditional Synergy let me do it, and yeah, it'll work fine. It may not be good practice, but I'm doing it because you always let me. So, best solution, fix the bad code. Okay, you're going to see a theme running through here, because it is, technically speaking, it's not great to be doing that kind of stuff. It could, depending on what you do in that routine, it could be the source of bugs and runtime errors in your code if the code doesn't deal with it properly. So if it is something that you look at it and go, yeah, that's just wrong, then fix it. But you can turn on one of, QRelax param has been there quite a long time. That relaxes those things that it says there. It lets you pass an alpha to an n parameter or a decimal to an input or unspecified direction alpha parameter. That's been there since version 9, I think. And QRelax param AD lets you pass alpha to decimal, which was recently added because it's a common thing that we needed to do to save you having a lot of work to do. So if you start finding those type mismatch for parameters, then QRelax param, as always, the best solution is ultimately, let's try and rework the code to get rid of this. The goal really should be, okay, we might turn on QRelax to get us past this today, but I'd like to, when I go back, I'm going to figure out what I can do to prevent having to do that. Okay?
So the param AD doesn't get rid of the errors entirely, it just converts them into warnings.
Turns them into warnings,
because we still think those ones in particular are very important for you to pay attention to.
Thank you, that's a good point. So param AD is not something that we initially allowed you to relax because potentially it is a lot more of a serious scenario. So as Jeff said, we've allowed you to do it, but yes, that's right, you're going to see a bunch of warnings now instead of just turning it off and going away, which is, param just turns it off. More argument values than declared parameters in routine, whatever. If it's something you've done intentionally, like, you've got this subroutine that you can pass any number of any combination of whatever and it figures it out and does its thing, and it's one of those kind of routines like a display statement, well, you pass it whatever you want in whatever sequence pretty much, then use the comma-var-arg subroutine modifier to allow that kind of behavior. If it's unintentional, and we came across with some customers' codes, we came up with, I think, 3 or 4 scenarios where you've got subroutines with 4 parameters, and this routine's passing it 5, and this routine's passing it 6, and it looks like it's stuff that should be working, but it's not. so seriously, if you look at it and you go, whoa, well, this is just wrong, then you're going to have to do a bit of thought and figure out what you're doing wrong there. So fix the bad code. External function X does not match prototype X, A with a function that returns an A or something like that. Typically when functions don't explicitly declare a return type. So again, best solution, go fix the bad code. Have the function declare its return type. But you can also QRelax DXTF to suppress that behavior if you wish. And basically that just says, don't worry, don't check the return type of a function. So you are relaxing things. Again, you could wind up with issues because of that. It is potentially a source of runtime type failures, but whichever way you need to go. Another type of common issues, symbol already uniquely defined in structure, whatever. Basically different data structures in different files with the same name. Again, we're in a single compilation unit type scenario here. It's going to find those things and they're going to clash with each other these days. Best solution, again, fix the bad code. Why have you got 3 structures with the same name that aren't the same? It's pretty bad practice. But again, you can QRelax allow dupe to get around that, again, on a temporary level, temporary basis. Cannot resolve type for field, and it's something at or an OO type or an enum typically, something or anything that was prototyped before. Basically, if you had some prototyped environments, maybe you've got a library of classes or something and it is prototyped, and you find that all of a sudden now DBL-Proto's throwing out problems that it can't find things, what's happening is it turns out DBL-Proto really wasn't that smart when it came to imports, and they've fixed a lot of stuff and now it is. So it's working properly now. But before it used to, what was the issue? Having imported something, it was basically available in subsequent modules, and now it's not. So what you might find is you're using some classes or enums or some kind of OO types that haven't, and the namespace for that type has not been imported in this particular source code because it was kind of happening automatically because it had been used somewhere earlier in the build. That does not happen anymore. So you might find you just need to add a few imports here and there if you've got some OO code. Visual Studio is pretty good at helping you do that, by the way. If you're on the undefined thing, there's a pretty good chance that if you hit Control period, it will say, oh, would you like to insert imports system.io or whatever, and do it for you. A little bit more information about the dependency-based build system. So MSBUILD, once you've set up this environment, it's going to understand it and know how to build it. You're not going to have to spend a lot of time saying, how do these things get compiled and linked? It just gets defined by what files are in the projects and inferred by what projects reference what other projects to define what links against what. If you've not worked in this environment before, on the build menu you will find you've got 3 primary options. They are build, rebuild and clean. So build does an intelligent what do you think needs building and build that. Rebuild, as its name suggests, will force everything to be rebuilt. And clean will go off and delete all of the output, the object files and executables and all that kind of stuff and clean up the environment. We shouldn't need to use clean too much. Jeff's use case yesterday is probably the primary one, that you're going to zip the whole thing up and send it to someone else, and you'd rather it was a megabyte rather than 300 megabytes. So, that's there really for. You can also build, there are options in the build menu you can specifically say build the project, so you're constraining it to just that project, or build solution or rebuild solution. So you can tell it, go build the whole thing, just build the project I'm working in, that kind of thing. Obviously, you can also, well, not obviously, some of you may not have seen it, you can also right-click on the project itself and say build this project or rebuild this project, and so on. Also, again, Jeff mentioned this briefly yesterday, you can, once you've got the environment completely set up, it is possible to build from the command line. So you can use the MSBUILD command itself with command lines similar to this. P colon platform is x86 and which configuration, and point it at the solution and it'll go off and build it. And it's, as Jeff mentioned yesterday, if you're on a multi-core CPU, it can be considerably faster because it builds it, it figures out, well, within the constraints of the dependencies, once it's got the low-level libraries built, it starts doing multiple builds on multiple projects at the same time. So it can be very significantly faster once the whole environment's set up. Especially in I've got a couple of customer scenarios where one of my customers has got like 3 ELBs at the bottom, and then there's like 25 projects of programs that all reference those 3 ELBs. So once the 3 ELBs are compiled, it starts building 4 at a time on my system, because I've got a dual-core hyper-threaded machine. So the only file extension this thing's going to know about out of the box is DBL. So if your source files have other extensions for either source files or include files, it's a very good idea to go into Tools Options, Text Editor, Synergy DBL is where all of the Synergy related configuration stuff is, and in there is an IntelliSense tab, and as you can see there's additional compile file extensions and additional content file extensions, which are include files essentially. And you just list .def, .inc, .fred, whatever it is in there, and that will cause all of the language sensitive features and IntelliSense and all that kind of stuff to happen in those other file extensions also. Another thing to be aware of is another place you might want to visit in the early days is in that same area in the text editor, Synergy DE. Look at the formatting tab. I apologize about the screenshot. I've messed with font sizes in my dialogues so that you can read things on slides. So the area on the right there that looks terrible on my system, on here, generally is quite a nice little pictorial view of a piece of sample source code that actually demonstrates the impact of the settings that you've got in the center of the dialog there, so that you can see how begins and ends and .includes and things like that are indenting, and you can tweak the tab settings and indent settings to get it looking as your code looks. And the point being that if you set it up correctly, you open one of your source files and it should appear as you expect with the same indentation. And clearly, well, maybe not clearly, but you've got a lot more control here than you ever had in Workbench. In Workbench, you pretty much got to pick one of our 4 styles. Here, you can pick one of our 2 styles and then start customizing it. So you've got a pretty good chance of being able to get to where you want to get to if the Workbench stuff didn't quite do it for you. Very briefly, as Jeff mentioned yesterday, this is just initial support. There's an awful lot more things that we're going to be doing. So obviously full integrated debugging support will be coming along as a sort of default fully supported behavior at some point, experimental right now. We know we need to add support for building toolkit window libraries like you could in Workbench. We know we need to have an xfnetlink.net component project so that you can build your xfnetlink assemblies like you could in Workbench. There's been some talk, I'm not quite sure what's happening here, but maybe some support for an XF Server Plus ELB project that automatically knows how to populate the method catalog based on attributes and all of that kind of stuff for you. So it can help you with that kind of environment. And maybe also something with the .NET Assembly API, so that if you're using GenNet 4.0 to generate traditional Synergy wrappers for your WPF controls that you're using to do your Symfony development to improve your toolkit app, then maybe coming is some kind of project type to automate all of that kind of process for you as well. And who knows, some other stuff likely as well. Okay, so I'm going to turn you guys loose in just a few minutes' time, but I thought I'd give you just a couple of quick demos. The first thing I'm going to demonstrate is just starting from scratch, just setting up something from new. So I'm not going to open anything that's pre-configured. I'm just going to launch Visual Studio. So here's Visual Studio. Basically, I'm just going to start totally from scratch. Let's go create a new project. Let's pick where this project is going to go. I have a... Oh no, let's do it this way. Let's go, actually, yeah, we'll just dump it in here. So that's where my solution is going to go. I'm going to create something called Object Library 1, and I'm going to name my solution My App, and we're going to go off and create initially our object, we'll create an Object Library project. So, I really did, I don't think I set that up. Have you been messing with my machine, Jeff? Thank you for that. It's like, I'm pretty sure I didn't leave this like this. Okay, yeah, a little extreme. So like in other Visual Studio project types, we create the base project for you. It doesn't have any references or prototype references by default. And we throw a little bit of sample source code in there to show you the kind of things you can do. So we got a subroutine called Object Library 1. Let's call this OLB sub 1, and we'll just let it do its thing. So clearly, I could start, working in here. If I want to add more files, I could right-click, add, new item, pick code file, and start creating new things in this project. By the way, when you guys are adding stuff into these projects, if you do it through manual setup, what I would strongly recommend is if you go into a project and say, add existing item, okay, you're going to browse and find the source files. And by the way, you can quite easily do things like, let me just pick any old piece of source code here. No idea what's in here, but okay, so you can, by the way, of course, do the control-click thing to pick multiple files at the same time. You don't have to add them individually. You can also do the shift-click thing. Another neat trick when you're adding, oops, didn't want to do that. Another neat trick when you're adding in source code is just to come down into the file name and say star.dbl, enter, and that will filter the box to only DBL, and now you can just pick them all. Okay, so quick ways of adding things in. However, be warned, if you do a file add existing item, what it's going to do is copy the source code into the project directory, which probably isn't what you want. Okay, so as with Synergy.net, we also extend Visual Studio with another option, which is add reference existing item. Sorry, let me do that again so you can see it. So you go right click on the project or file add or whatever. So file add reference existing item. The difference is you still browse off and pick the source files, but it puts a relative path reference, relative if it's on the same drive, reference to that existing source file in its current location. So now you can open up your Workbench environment and work on it, or open up your Visual Studio environment and work on it, and you're working on the same physical file. It's not going to copy it. So that's almost certainly what you guys want to do, unless you've just brought a big pool of source code and you're just going to set up a completely new environment from scratch. Maybe then you want the source code in with the projects like you would normally have in a .NET type development environment. So there's our object library. If we go and look at its project properties, it's going to be called Object Library 1. It's going to be built by default to a bin, debug x64. Let me show you the process I would generally go through. So I created this folder in here, and it's called My App. What I would typically do is say I want all my object libraries to go into the same place. So I'm going to create a folder under my solution called lib, and I'm going to create a folder under my solution called exe, and that's where I want my OLB'S and DBR'S to go. And then I'll show you how I would generally use the common properties to set up an environment so that things build into those places. So let's do that now. We'll go to our common properties. Oh no, I guess, God, what's happened to my font sizes? Okay. We will click on Use Common Properties, and I'm going to set up one called lib, and I'm going to give it a value of $solution dir, and I want all my object libraries to be in the lib folder below solution dir. I apologize about the font, I can barely see it either. Slash, and then we'll use $configuration and a slash and $platform. So basically I've said lib is based on the solution directory, the lib folder, configuration, release or debug, platform, x86 or x64. So having done that, I can then go to my build tab, and I'm going to say in all cases, so for all configurations, for all platforms, I would like my object library to be created in lib:. Okay, and if we save that, that's now what we should get. So if we do now a build on this project, we should find that under lib, we've got debug, x64, and there's my object library. Okay, and if we switch to maybe release mode and do a build, we should now have lib release x64 and the object library. And the same would happen with the executable directories. I'm not going to go through that and do it all again. But so basically set up a logical name in common properties that is based on configuration and platform-based paths, like that, and then use that logical name to define where things need to go, basically. Okay, let's very quickly step through. Let's add a second project. So we're going to do a add. We're going to do a new project. This time we'll have an executable library. I'll let it just default to executable library 1. Again, there's our ELB. I would maybe name this, let's call it ELB sub 1. So now we've got an ELB. Maybe this one xcalls OLB sub 1. Oh, okay. I'm not getting IntelliSense because I haven't referenced the project. So I'm going to call into the object library from the ELB. So I'm going to add a reference, and I'm going to go to my projects and reference my object library. And now in my ELB code, xcall OLB sub 1. There's my IntelliSense coming in, okay, because I added the reference. And if we do a build, everything should be fine. Now I haven't set up the output location, so it's building to bin debug x86 underneath my project, not into my exe directory. But as you can see, everything worked just fine. Then let's add in some programs. So we're going to add a new project. We'll go with traditional multi-mainline. We'll leave the project name on its own. And this one, again, we're going to go off and add our reference to our ELB. Okay, and now in our program, we should be able to xcall ELB sub 1 because we've got our references in place and everything should happen. Now again, with ELBs, I'm not going to do it right now because I want to get you guys up and running. But with ELBs, clearly it is critical that you do configure the build output path using a logical name, because that's what the reference in the DBR is going to be to the ELB, and that's what it's going to use at runtime. Okay, so it's critical that you absolutely need to set this output path in ELB projects. The output path must be a logical, because that's what the linker is going to use when programs are compiled against that library. And therefore, if you want it all to hang together at runtime using your logicals, you really need to do that. Okay, but as you can see, everything works just fine. And if I do a rebuild solution, so everything's been forced to be rebuilt, and then it's actually hard to show you in this environment because it builds so quickly. You get the idea. Let's move on to, let me show you briefly let me show you the conversion process, the Syn to VS, in case you want to do that. So to show you that, I'm going to go off to here. Let's use Van Diest. So this is a fully configured customer environment. I've actually got everything configured already in here, and these are all my projects and solutions. But I'm actually going to show you how the Synergex tool works. So I've actually set up a batch file to do that. So generate VS solution, if we look at the batch file, all it does is it puts that directory that we talked about in path, and then it says Synergex from the workspace file. Okay? Just to prove there's no smoke and mirrors going on right now, my workspace file is here. You'll notice there is no vandiest.sln, there's no solution here. And if I look in, all of my Workbench projects are in PRJ. There's the SDE and VPJ files, but there's no Visual Studio projects there, there's no subdirectories there, okay? So let's just go off and run that batch file. So all it's doing is Synergex on this workspace, and it's done its job. As Jeff said, it leaves behind these work files right now for debugging purposes. That's kind of proving to me that it's been through all these projects. There's the solution that it just created. There's the projects that you'll notice. There's our Workbench projects. Now we've got subdirectories for all the Visual Studio projects, and each one of them has its Visual Studio SynProj in there. So in theory, I should be able to go and open up this solution file that was just created, and we should get a fairly comprehensively configured environment. Okay, so this environment has basically all the projects. Let's do a collapse all. There's all the projects. You can see I've got 1, 2, 3 ELBs. This is an XF server plus ELB, so is that, and then all of these are sets of programs. I think across this system there's like 2,800 programs in this environment, and we just set up the whole development environment, apart from environment stuff. So now what I would need to do is I would start at the top, and I would go into project properties, and I would turn on use common, it is on by default. The converter turns it on by default, start setting up my configuration in here, and then I'd have to go one time. No, I wouldn't, because it's turned on by default. Yeah, so the Synergex tool enables common properties, but there's no properties set up. The advantage of that is you just go into one project, set them up, and it's automatically turned on in all the other projects already as well. Okay, so that's what you would have to do. Let me just show you a version of this that is completely configured. So if I go not into that directory, but I have already configured in VS Dev. So this is the solution that I pre-configured and set up manually. I used to launch this environment through a batch file that set up hundreds of logical names and all kinds of stuff. Now it's all just done through common properties. And this is the customer's actual environment. So if I go and ask it to build, library UTS is their kind of main ELB. So if I ask it to go do a build on library UTS, then, library UTS depends on net wrappers, so it made sure that net wrappers didn't need building, and then it actually found that nothing needed building. MSBUILD went through it so quickly I can tell it didn't build anything. If I want to force it to rebuild that library, I can just say rebuild library UTS, which of course will first rebuild net wrappers because it depends on it, and then it will build library UTS and it's finished. Okay? If I go to, let's go run a program. This one should already be configured to set up to run their menu, I believe. Let me just check that. Where are we? Application, yes. So in the UT project, if I wanted to work on a particular program, if I do a build on this project, everything I believe right now should be up to date. So if I just do a build, it builds checks the dependencies. Oh, it looks like it is doing a build. Something needed building in UT. So just bear with it. It shouldn't take long.
You just forced an update on that one, so it knows.
Oh, right, because I was in the project properties. Is that why?
You just rebuilt that base library.
Oh, of course. Yeah, okay. All right. So now everything should be up to date. So if I do a build, it'll go through them. Yeah, you see how fast that was? Because nothing needed to happen. Everything was up to date. Okay. If I go and edit one program, and just make a change to that program, I'm just going to insert a space and hit save, and now do another build, literally slower than I thought it was going to be, actually. Okay. Maybe we have something to look at. Okay, there we go. Trust me, it didn't build the whole thing, because I've done this in other projects that take 10 minutes to build the whole thing and it's not doing, but I'm not quite sure what happened there. Just to show you how things run, so this project, you can see the project is bold there. That's because I've said set as startup project. It's kind of similar in concept to a web development environment. You can say this is the startup project, therefore if I just hit start, that's what we're going to start, and within this project we're going to start whatever is the startup object. So you can set that in the project properties. Also, you can also right click on a file and say set as startup object. Or I could just right click on any, regardless of whether it's the startup object or not, I can right click and say start debugging, start without debugging, and so on. So if I just hit run, it should launch that program. There we go. And in theory, oop, what did I do? Uh-oh. What happened? Oh, did it hit a breakpoint? Tools. Delete all breakpoints. Okay. I apologize, it's a demo, it's not going to work today. But you can see the program's running up. I'm not sure what's going on in the background there. That might be something, that might actually be something. Their software checks a bunch of criteria and then chains on to different places depending on what it finds and stuff, and it might be something in my setup with their software actually that's not behaving there. But you get the idea. Once the thing is set up, hitting start or start without debugging starts the default, or I can right click and say start debugging, start without debugging on individual programs. Okay, so there's an example of a real customer environment. Are there any questions about any of that? Okay.